In this first video for Chapter 7, we're going to take a look at inverse functions, which play an important role in calculus and integral calculus and in application problems. So let's first define what we mean by an inverse function by looking at this picture. So we have a function y equals f of x, which is this function here. We have its inverse function y equals f inverse of x, which is here. And we want to characterize a function and its inverse in three different ways. First is that the function and its inverse are reflections of each other about the graph of y equals x, this graph right here. And second is that if the point xy is a point on the graph of f of x, so that's, let's say this is the point xy, then the point yx, the corresponding point yx, would be on the graph of f inverse of x. So one way to think of functions and their inverses, or a second way to think of them, is that take all the ordered pairs xy, flip them around to yx, and you've got the graph. And the third way to think about a function and its inverse is as a series of rotations of the original graph to get to the inverse. So let's look at that by looking at three graphs on the next blackboard. So let's start with this graph right here, y equals f of x. And then first we are going to rotate it forward 90 degrees to get this new graph right here. And then we're going to rotate that graph around the y-axis 180 degrees to get this graph right here. And if we label them, the original graph is f, and the one that we wind up with is f inverse. Notice that it makes sense also in this respect that this point right here is xy, and this point, this corresponding point on the inverse, is yx. Let's take a look at a specific example on the next blackboard of what a function and its inverse look like on the same graph. So we're going to use a two-step process to go from the graph of a function to the graph of its inverse. First, we are going to switch x and y. And so when we do that, we get x equals y cubed, and then we are going to solve for y. And when we do that, we get y equals the cube root of x. And we can take a look at these two graphs on the same axis and see that all three of these aspects that we've discussed work for this function and inverse. So here is y equals f of x, y equals x cubed. So you see that the graphs are reflections of each other across y equals x, that the point 2,8 on the graph of the original has its reflected point or flipped coordinate point 8,2 on the graph of the inverse. And this part's a little bit harder to see, but if you flip it 90 degrees forward, the original graph, you would get what this, and then if you rotate it 180 degrees about the x-axis or the y-axis, you get to the graph of f inverse. So in some cases, going from a function to its inverse is pretty easy to do. Let's take a look at another example now where we run into complications. So here we're trying to find the inverse of this function. If we switch the variables, we get what? X equals y cubed minus 7y squared plus 5y plus 20. But we are not able to solve for y. In general, we cannot solve for a function when that function, or solve for a variable, that is, when that variable appears to more than one power. We can't isolate the variable. But let's take a look at the graph of the function as inverse. We can do that. So here's the function, and here's its inverse, and you can see there are reflections about the line y equals x, and their coordinates are flipped. You can see it maybe best with this point right here has as its corresponding point with the coordinates flip, right? This point goes to this point, and I guess another one would be what? This point right here goes to this point right here. So we can always find the graph of the inverse function by the flipping or the reflection method, but in general we're not able to always find the inverse function solve for y. Now this right here, this is the inverse function. We just have to leave it solve for x. So let's make this a very short video just on section 7.1. We'll come back to needing to find inverses as we develop the theory in this part of the chapter on logarithmic, exponential functions and hyperbolic functions, where we need to work with functions and their inverse to develop the calculus. So that's the end of this video on section 7.1.